Okay, today what we're talking about is section 7.3, exponentials and logarithmic functions. Up to this point, we have covered nothing but exponential functions, and now I'm going to introduce its inverse, which is what a logarithmic function is. So when we talked about inverses, we talked about being a function first, passing the vertical line test. Then we talked about being a one-to-one function, meaning for every one x, there's exactly one y, and it passes the horizontal line test. Okay, so let's go ahead and plug in a couple values here for you to be able to see 2 to the x. So if I'm graphing 2 to the x, I'm going to have 2 to the negative 2. Sorry, wrote the wrong thing. Negative 2 to the negative 2, 2 to the negative 1, 2 to the 0, 2 to the 1, and 2 to the second. 2 to the negative 2 means it goes down to the bottom and becomes 2 squared, which is going to be 1 over 4. This is going to be 1/2. This is going to be anything to 0 power is always and forever 1, and anything to the 2 to the first is 2, and 2 to the second is 4. So if I graph this, I have 0, 1, I have 1, 2, and I have 2, 4. And then over here, I'm going to have negative 1.5, and then negative 2 1/4. And what you have is this exponential function, okay? The domain, if we read it from left to right, says that x is an elm of the reals, and it goes on forever in both directions. The range, I don't run into the graph until I get to 0, but that means y has to be greater than 0. And then my asymptote is going to be, my horizontal asymptote is going to be at y is equal to 0. That is what an exponential function looks like. Now, I'm saying all this because I'm not going to make you guys have to do all of this. I'm just showing you what the graph looks like. So if we do this, this is what you see, and you say, is this a one-to-one function? Does it pass the one-to-one function, a horizontal line test? The answer is yes, it does. What that means is I have an inverse. My inverse means that I can swap my x and my y, and I'm going to get this graph right here. This is the graph I graphed earlier, and then we are going to be graphing its inverse, which is log base 2 of x. Now, the beautiful thing about this thing is that whenever you graph this thing, it is going to go across the line y equals x, and they're going to reflect across each other. And you can clearly see that that's what's happening here. It goes over and they reflect across each other, and they're equal distance. What do I mean by their equal distance? Well, look, they're equal distance from one graph to the other graph, from the other graph to the other graph. They would be equal distance from each other. Okay, so now with all of that being said, this is just the history of it. You don't actually have to know this. I needed you to understand what a logarithm was. A logarithm is going to be the inverse of an exponential function. And you are going to read it as the following. Log base b of x is equal to y. Log base b of x is equal to y. That means that the inverse of it is b to the y is equal to x. Okay? What I've highlighted is what you need to understand. Our brains think in exponentials. They do not think in logarithms. So we have to translate each log into an exponential function. So what does that mean? How do we go about this? Well, you are first going to find the base of the logarithm. The base of the logarithm is going to be the base of the exponential. Then you are going to look across the equal sign, and you are going to grab that x, and that x becomes your exponent. And then that is going to equal our large number, which is 32. And that is how you write it as an exponential. So 8 to the x is equal to 32. How do I write this one? Well, I'm going to set this thing equal to x. Why? Because it's not equal to x. And I'm going to grab the base. The base is a 5, and that becomes the base of my exponential. Look across the equal sign. That becomes your exponent, and that is going to equal 125, which is our big number. Now, I didn't solve either one of these. I just wanted you to be able to write them back and forth. But now we're going to go back and we're going to solve them. Now, our goal here is to make the number 8 and the number 32 to have exactly the same base to a power. So how do I rewrite 8 to be a number raised to a power? Well, 1 to any power is going to be 1. 2 squared is 4. 2 cubed is 8. So what I'm telling you is, if I take 2 and raise it to the power of 3, that gives me 8. Well, how about 32? Can I rewrite 32? Absolutely. Well, if 2 cubed is going to be 8, then 2 to the 4th is 16. That means 2 to the 5th is going to be 32. So 32 can be rewritten as 2 to the 5th. So now that my bases are the same, I can set my exponents equal to one another to give me 3x is equal to 5. So then x is equal to 5/3. So let's do that again with this one. 5 to the x is equal to 125. Well, 5 is a prime number, so I have to try to express 125 to 5 to a power. Well, 125 is going to be 25 times 5, and 25 is 5 times 5. So that means 125 is going to be 5 cubed. Now, my bases are the same, which means my exponents have to be the same, so x is equal to 3. Okay? Evaluate using logarithms. So we're going to make this thing equal to x. So now I'm going to say 4 is my base. I look across the equal sign and I grab my x and I set that equal to 32. 4 is the same thing as 2 raised to what power? How about 2 squared? 32 we learned in our first example was 2 to the 5th. These are attached by multiplication, so you multiply those together. And then you have the same bases, so you are going to have 2x is equal to 5, which means divide by 2, x is equal to 5/2. Okay, next one over here. Set this equal to x. My base is 64. Go across and grab the exponent x, and this is 1/32. Okay, well, let's think. We already know what 32 is. 32 is going to be 2 to the 5th. But that's in the denominator, and I want to move it to the top. Well, to move it to the top, that's going to be 2 to the -5. Well, if 2 to the 5th is 32, then 2 to the 6th is 64. Multiply these exponents to give you 2 to the 6x is equal to 2 to the -5. Then you simply knock off those bases and you get 6x is equal to -5. Solve for x and you get -5/6 is equal to x. Okay? Next, the common log. The common log says that anytime you have a base of 10, it's understood to be there. It's kind of like 1x. I don't have to write that, that's just simply x. So if I have log base 10 of 1,000, that's the same thing as writing log of 1,000. It is understood to be there, so you don't have to write it. But it's still the same concept. So if your brain likes to keep it there, there's no harm or foul. You just simply set that equal to x and you say, okay, my base is 10. I go across the equal sign and grab my exponent, and then I set that equal to the large number. 10 is going to be a number I can't break down, but what I do know is that I can rewrite 10 or 1,000 to be 10 to the 3rd power. Now that tells you that x is equal to 3 by marking off your bases. Okay, let's do it again. Well, how do I solve these exponentials? Well, these are super easy. I need to go backwards and I need to write my exponential as a logarithm. So what is the base of this exponential? It's 10, so I'm going to write the word log base 10. I'm going to have an equal sign. I'm leaving a space there. And my power is what is going to go down here, so that's going to be 2. And then my number 100 goes right there. Again, my base is 6, so I write the word log, and I have 6. Then I leave a space, and this exponent is going to be what it equals. And then I simply drop the 36. Write an exponential function as a logarithmic. Okay? Which one has the exponent? The 3 has the exponent. So this is going to be log base 3, leave a space, put the power as 0, and then drop down the 1. Over here, which one has my power? The 2/3 has my power, so this is going to be log of 2/3 small, leave a space, equals, drop down the power, and then drop down the bigger number. Okay, E. E is going to be my logarithm, log base E, leave a space, drop the exponent, and this is 7.93. Now, this right here is shorthanded down to ln of 7.39 is equal to 2. Every time you see the letters ln, that's what we call the natural log. The natural log. ln is log base E. They are the same thing. Tonight's homework is 7.3 worksheet 1.